Hello everyone, welcome to my channel Code with Sunny, and today I am going to discuss the problem palindrome linked list. Index number is 234 and the problem is of easy type of LeetCode. Okay, so let's read out the problem. Given the head of a singly linked list, and we have to return true and false depending upon whether the linked list given is a palindrome linked list or not. Okay, so basically palindrome linked list, we have to check according to the values present in the nodes of the linked list. Okay, so suppose here we have an example like 1221 and it is a singly linked list. You can see the arrows are going to be like in the same direction, and okay, so the you can see starting one is exactly equal to the end of the value of the node of the linked list, that is 1 exactly equal to that of 1, and the again 2, that is the second element of the linked list node, has the value exactly equal to the second last element of the node of the singly linked list. Okay, and these are the equal because it is a palindrome. Okay, we have to return true here, and in this case you can see it is not a palindrome, example number 2. So how we are going to do that in the best possible way, and what should be the approach to solve these types of questions? Okay, so let's look over the constraints also. The number of nodes in the list is in the range up to 10 power 5, and nodes values goes up to at most 9. Okay, and there is a follow up also. Could you do it in O of n time and O of 1 space? Okay, so there is a challenging question. We have been challenged that we have to perform solve this problem in O of 1 extra space. Okay, so let's move further to analyze this problem with the help of examples and what should be the approach to solve these types of questions. Okay, so let's move further. Okay, so here you can see I have taken two linked list, two different length of the linked list. One is of odd length and other one is of even length. Okay, now the first approach that comes in our any of the minds of the students or the viewers, that is, suppose we have been given this linked list, so why not store the values of these linked list into an array, into an array like this one. Okay, let's say it will have a value like 2, 3 and 3 and 2. Why not store these values into an array 2, 3, 3 and 2, and check this array is a palindrome or not? And if this array is palindrome, I am going to return true, otherwise I am going to return false. So this is the basic first approach that clicks on the viewer's mind or the coder's mind. Okay, now one thing that is observed here is that in that case the time complexity will go up to O of n, and the space complexity would be also O of n. And why this should be O of n? This should be O of n because you can see I am going to maintain an extra array of n size, so it would become time, space complexity would be O of n and time complexity would be O of n. And for checking palindrome, it would be also O of n, time complexity. So overall time complexity would be O of n and space complexity or O of n. But this is not the good solution of this problem. So what should be the good solution of the problem? Can you think that? Okay, so let's leave it and let's now understand this with the help of the key points, how I am going to solve this problem in the best possible way. Okay, so let's move further. So let me erase this stuff now. That is really very annoying. Okay, okay, it is done now. Okay, so for having a, okay, so let me write, for having a O of n time and O of 1 extra space, I need to think of best efficient solution of this problem. Okay, so note that I need to check the palindrome, whether my linked list have the nodes whose values form a palindrome, whose values are palindrome or not. Okay, so let's suppose it will have a value 2, 3 and 3 and 2, and we need to check if this is a palindrome or not by in the efficient way. Now, so, okay, so what I'm going to do is just first find out the number of nodes in this linked list, that is n. N is going to represent number of nodes in this linked list. How I'm going to find this n? It is simply just traverse this linked list in O of n time and find out the number of nodes in this linked list. Okay, now there are two possible cases for this n. One of the possible cases is n is going to be even, and other one is n is going to be odd. And in case of, you can see, in case of an even length, I need to partition my linked list up to this one, that is these two nodes and these two nodes. I need to check if these 2 3 and these 3 2 are palindrome or not. Okay, that is 2 3 if reversed is exactly equal to the is exactly equal to the, you can say, the values that are present to the right of this n by 2 length of this linked list. Okay, and now if n is odd, what should be the parameter for checking? You can easily see, I can easily ignore this node because it lies at the exactly at the middle of the linked list. So I need to check this one and this one. Okay, now the question, now the main problem arises that how we are going to solve this problem without using any extra space like an array to store the elements, exactly all the elements. How I am going to do that? Okay, so I'm going to just tell the best efficient way of this solution. Okay, so let us first erase this one. Now you can see what I'm going to do is I'm going to just find out the exactly middle partition, or you can see the exactly middle value where the palindrome, where I need to divide this linked list for the checking of the palindrome. Okay, now for this one I am going to divide this linked list here, and for this one I am going to just divide this linked list here, that is after this one. Okay, and you can see, let's suppose here also we will have the values like 2 3, and here let's say it has a random value as 6, and here it is 3, and here it is 2. Okay, now I need to have the palindrome to have the palindrome words, or to have the palindrome numbers exactly equal to that of here and to that of here. I need to reverse this linked list, and if after reversing this linked list like this one, so if I'm going to reverse this linked list like this one, again it will have the values like same. Okay, but here we will have one benefit. And what is the benefit? I can just traverse starting from here. Okay, so it will be like that. Let me explain. So I can traverse starting from here, and every iteration I can jump to the next of the node by using the pointers. And in this case I cannot directly go to the end of the linked list and just go in the reverse side, because the arrows are pointing in opposite direction. So I need to reverse this linked list in O of n time. So how I am going to do that? So I'm also going to tell how we are going to reverse the linked list in an efficient way. Okay, so the approach of this problem, that is the best way to think upon this problem, is first we need to divide this linked list such a way that the what we actually need to check, what we actually need to check those nodes that are going to be involved in the palindrome numbers. Okay, so that is these two numbers, and the last these two numbers. Okay, first n by 2 numbers, an integer value of this n by 2, and last n by 2 numbers. And for the last n by 2 numbers, the key point is I cannot traverse from the back side of the linked list to the opposite direction, because the arrows are going to point to the rightwards. Okay, I cannot move to the leftward efficiently, and also I cannot jump directly to the end of the linked list. So the main logic is to just, why not to reverse these arrows of the linked list. Okay, so if I'm going to reverse these arrows of the linked list, I'm just going to start with the rightmost end of the linked list, and at every iteration I'm going to just move from head of the linked list, that is this one, to its next, and also from the back of the linked list, that is this one, to its next efficiently. So I can check the whether my palindrome, whether my linked list is the palindrome or not. Okay, so let's have an overview of that, how it is going to happen. Okay, so suppose I have a linked list over here, that is I'm going to draw this 5. Okay, so it will be like that, this one, and it will be like this one. Okay, so the values are correspondingly like 2 3, and let's say it will have a value 7, and again let's say it will have a value 3, and let's say it will have value 2. Okay, now what I'm going to do is just break this linked list into two parts, that is this one. So my one half of the linked list should be like this one, and other half of the linked list would be like after this one, last n by 2 values, because here you can see n is going to be odd, and this node is not going to contribute in like checking the palindrome. Okay, because n is odd. So my remaining part of this linked list should be like this one, and but I need to traverse the linked list efficiently to check the palindrome. So I am going to just reverse this linked list. So if after reversing this linked list, my linked list would become like this. Okay, so the values are like, let me write down 2, 3, and 3 and 2. So let's start from the head of the linked list, and let's start from the end of the linked list. And each time I'm going to check if head's value is not going to match with end's value, just return false because it is not going to be palindrome. Otherwise, increment head to its next, and also increment end to its next. Why end to its next? Because you can see I have reversed the direction of the arrows. You can see easily over here. So I can traverse from the back side also. This is the main advantage that after reversing the linked list. Okay, so this is the main logic of this question. Now also there is one more question: how we are going to reverse this linked list efficiently? Okay, so no need to worry about, I'm going to explain that also. Okay, so let me have a quick erasing. Let me erase this stuff also. Okay, so okay, so let me erase this one. Okay, okay, so now let's understand how we are going to reverse the linked list efficiently. Okay, so let me have this okay, so let me have a this 3 node. Okay, now you can see for reversing a linked list efficiently in O of n time without using any extra space, I would be doing like that. Okay, so let us maintain 3 pointers. Current, that is going to be at like head, pointing to the head, and one pointer I need to store for the previous nodes and let it be null initially. And note that here it is, I'm going to just start from the entire beginning of the linked list for a particular linked list, but in this case I need to start from this one. That is, my current should point to the address of this node. Okay, so you must be careful about that also. And again, after current and previous, I would be have like I'd be applying n1 next node, it is also going to be assigned as null. So for if while current is not equal to null, I have to check. Okay, so I need to just reverse this arrow. You can see I need to have this arrow like this. So why not store to the next pointer previously? Okay, so I am going to just store n1 as currents next. Okay, so if I am going to store the currents next, because for I need to traverse the linked list also, so I need to store a c1's next, that is currents next. Now I can easily assign this node as okay, so I'm going to assign currents next can be assigned as previous. So I'm going to just assign currents next as previous. Okay, if it is done, my next previous for the next iteration would be like this node. So I'm just going to assign previous as current now. So if it is done, what is my next for the next iteration? I need to have like current equal to the address of current equal to address of this node. So I need to assign like current equals n1, and I'm going to just write these 4 statements till current is not equal to null. So this is how I'm going to reverse the linked list. If you are still confused, no need to worry about. I'm going to explain that also in the coding part. Okay, so let's move further to the coding section. Okay, so I have written the code over here and still I haven't run this code. I am confident enough that I can have a full AC solution at one time. Okay, so okay, so what I'm going to do, I've just written 2 solutions. One is the O of n time and O of you can see O of n space. Let us have a look over it also. So what I'm going to do in this case, just maintain a stack to have the nodes, that is for the last, that is for the node value of the last of the linked list will be at the top of the stack, and then I'm going to iterate from the beginning of the linked list and check the values, that is from the at the top of the stack value, at the top of the stack value, and also at the current nodes value. Okay, so just iterate till current is not equal to null, and just push the nodes values in the stack. So finally, after traversing the entire linked list, I will have like the end of the linked list has the node whose value will be at the top of the stack. And now again I am going to iterate in this linked list and check if at any time it is not going to be possible. that at the top of the stack has the value different to the current node's value, just return false, because it is not possible that our given linked list should be a palindrome. So it would be like while string, or oh sorry, while stack is non-empty and check stack top is exactly equal to current node's value, just pop the element from the stack and move to the next node address. Okay, and do this until stack is non-empty. At any time after doing this traversal, if return stack dot empty, because if stack is non-empty, I could not have a palindrome linked list. Otherwise I will have a palindrome linked list. Okay, so this was a O of n time and O of n space solution. Let me run this code now. I guess it would pass. I don't know. So let us see. Yes, it is good. So this was the O of n time and O of n space solution. So okay, now let's discuss the another solution having the time complexity as O of n and the space as O of 1. Okay, so as I've already said, n is going to denote the length of this linked list. Okay, and now you can see I have a current pointer that is going to calculate the what is the length of the linked list. Okay, in O of n time. Okay, so calculate the length of the linked list in O of n time. Okay, now you can see every time I am going to increment n, just move to the next node address while current is not null. And now let me write the base case. If n is going to be 1, just return true, because it will be always palindrome linked list. Now so I am just written list node end equal to head. Now what is this end denoting here? Let me explain this with the help of this diagram. Okay, so basically you can see end is going to denote this node if n is going to be even, and if n is going to be odd, end is going to be this denote, that is the n by 2th, that integer value, that is n by 2 n by 2th node of the from the starting of the linked list. So if n is going to be like 5, so 5 by 2, integer value of 5 by 2 is 2, the second node second node from the starting of the linked list. Okay, so this is going to be end, because I need to just break this linked list. Okay, that is first half and the second half, such that I need to include those nodes which are going to be checked for the palindrome. Okay, because if n is going to be odd, I need not to check this one. So let us move further. Okay, so end is going to denote that. Let us iterate and find out the extreme, what is actually the node's address that is going to be holded by this end node. Okay, so just iterate up to n by 2 and end equals ends next. Okay, and if n is going to be odd, I need to have a current. Okay, so I have another, I am going to assign this current as ends next and next if n is going to be odd, and if n is going to be even, just assign current as ends next. Okay, so what is this? Okay, so let us understand that also. Okay, so if n is going to be like this one even, you can see I need to break this, I need to start another part of the linked list after n by 2. So if n is going to be even, our end would point in this direction, so I need to have like ends next, which would be this one, that would be the starting of the new linked list. Okay, that is after n by 2 part. And if n is going to be odd, you can see I will have a starting of the linked list from this one. Okay, that is from node equal to 4. So how I am going to do that? If end is this one, so if end is this one, just go to ends next and then again go to this ends next. Okay, so this is what I am going to do. And so current is basically the starting of this new linked list after n by 2, that is going to be checked for the palindrome. Okay, now start reversing the linked list starting from current. That is what I am going to do for checking the palindrome condition efficiently for the linked list. Okay, so I am going to just maintain two variables, previous and next node. Previous is assigned as null, next node is also assigned as null. So while current is not null, just this loop I am going to write while loop reverses the half of the linked list. Okay, now next node is assigned as currents next, and just assign currents next as is previous to reverse the arrow, and just previous again as current and move to the next one. Okay, for further processing of the linked list. Now previous finally will contain the last node of the linked list. Okay, now I need to start from previous and I need to start from the head. Okay, So my current one would be head and current two would be previous. Okay, now if I am going to just march forward, that is like current one equals current one's next, and current two equals current two dot next, current two's next. It is valid because I have reversed the arrow for current two. That is for other half of the linked list after n by 2. I have already reversed, so it will be valid like current two equals current two, current two's next, it will be valid. Okay, so just n equals n by 2 because I need to check half of the linked list, and just check it out while n is positive. If current one's value is not equal to current two's value, just return false. Our linked list cannot be palindrome. Okay, so check palindrome condition, and otherwise just march forwards. Current one equals to current one's next, and current two equals current two's next. Okay, so let's submit this code. I hope this would be fine. Yes, it is good. So if you have any doubts, do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.